Hello everyone, welcome to another video. From the cycloid curve, we have already seen that if the circle is rolling along a straight line path, then any point on the circumference of the circle traces a curve which is called as the cycloid curve. That is, in this video, the point in red color is tracing the cycloid curve. Now, instead of tracing the point on the circumference of the circle, what if we have to trace a point inside the circle? Here, the distance of the point from the center of the circle should be specified in the question, and we will get differently shaped cycloid, a little bit different from the normal cycloid. In this video, I am going to show you how to draw this kind of tricky cycloid. This is Arjun, and let's make it simple. Here we are going to see a tricky problem related to cycloid curve. The question is, a circle of diameter 55 mm rolls along a fixed straight line. Draw the path described by a point P located at a distance of 20 mm from the center of the rolling circle for one revolution of the circle. So that means the circle is having the diameter of 55 mm and the point P is located at a distance of 20 mm from the center of the rolling circle. So we can draw the figure. First step is to draw the circle of diameter 55 mm. Here the point P is located at a distance of 20 mm. So the second step is to draw another circle which should be concentric to the 55 mm diameter circle with a radius of 20 mm, like this. Now the third step is to draw the straight line which is having the distance of the circumference of the larger circle, that is 55 mm diameter circle. Now the fourth step is we have to divide the smaller circle here into 12 equal parts. Previously, in the normal cycloid, there was only one circle and we have divided that circle into 12 equal parts. But here we have to divide the smaller circle into 12 equal parts. Now the next step is to divide the straight line here into 12 equal parts. The straight line is having the distance of 172.78 mm. So for dividing it into 12 equal parts, we can draw another straight line with an angle of 30 degree starting from the point here with a distance of any value which is divisible by 12. Let's say I am going to take 120 mm with a 30 degree angle. Next, we have to divide this particular straight line here into 12 equal parts. Now I have divided the straight line here into 12 equal parts. Next, we have to join this end point of the straight line here with this end point of the horizontal line here. Now we have to draw parallel lines parallel to this particular line here, connecting each and individual division points on the inclined straight line here. Now the next step is we have to connect horizontal lines through each and every individual points on the circumference of the smaller circle here. Like this. This line here is the central axis line of the circle which is passing through the center of the circle. The next step is we have to draw vertical lines starting from each and every individual division points on the horizontal line to the central axis line. Now we will get different intersection points on the central axis lines. These intersection points are considered as different centers. Next step is, with the center C1 with a radius of 20 mm, that is the radius of the smaller circle, we have to draw an arc on the straight line connecting 111 here. Like this. Now with the same radius of 20 mm, we have to draw another arc with the center C2 on the straight line connecting 210 here. Then with the center C3, we have to draw another arc with the same radius of 20 mm on the third line, which is line passing through 39, which is the central axis line. Similarly, we have to repeat the same procedure with all the other center points with the same radius of 20 mm. Finally, we can draw a curve starting from the point 12 on the circle here through the intersections of arc and straight lines. So this is how we can draw a cycloid curve when it is asked like this. Hope you understand the concept, and also the procedure of drawing tangent and normal is exactly the same as that of the general normal cycloid. Hope you understand the concept. Thank you very much. Please like and subscribe. Thank you.